Good morning, everybody. Welcome back to lecture number
40.
40.
Yes.
So last time we talked about sub-transmission system. What is the sub-transmission system? Sub-transmission system is a system used between transmission and distribution, and it usually has voltage levels between 69 and 138. And the goal of it is to make sure that we don't jump directly from the transmission. We like this figure from transmission all the way to distribution. So maybe you have another transmission line called sub-transmission before a distribution substation. So anything here and above 69 kilovolts, either transmission or sub-transmission. Here it's distribution. Everything here is distribution. In this chapter, we will examine the distribution system, the nature of prominent types of loads, and the power quality considerations to keep the power supply voltage at rated condition, frequency, and rated condition. So power quality is measured by two factors: the voltage level of the power, the voltage level with frequency. They have to meet the standards. He's telling us approximately 9% of electricity is dissipated in transmission and distribution system. Most of it in the later, and most of it where? In the distribution system. Why? For simple reason. For transmission, we have S equal 3VI conjugate. For a transmission, for let's say 100 MVA, maybe if you have a voltage level of 340 kV, what is the current magnitude? I don't know. 100 MVA over 3 times 340, say 380. Kilo, what's the answer? 90 amps, 9 amps?
119 amps.
119?
Kilo?
Amps.
Oh,
No. 87.71.
Well, let's make it a small system. Let's make it 10 MVA.
87 left.
Let's make it simple. 10 MVA. What's the current? 10.
8.77. 8.77.
So let's say 10 amps, صح? 100 MVA is a big system. You need more than one line to transfer the power. So what is the real power losses? 3I squared R. Let's say R is 10 ohm. 3 times 100 times 10. That's roughly 3 kilo. صح?
Yes.
Okay. For distribution level, let's say S equal 10 MVA, which is equal to 10 MVA. Okay, V. Let's say V is what? Distribution level. Let's say it's 13.8. What is the I? 10 MVA over 3 times 13.8. Key.
241.
What?
241.5.
241. So what is power? Let's say it's 3I square R. Let's say R is 10. No, it doesn't matter. 3 times 240 squared times 10. What are the losses?
1.75 megawatt.
1.75 megawatt. So you can see it's more. For the same power, it's more in the distribution than in transmission. This is just simple calculation, not accurate. Okay? So the objective of the power distribution system is to deliver the electric power to customers in safe, reliable, and most economical way. Okay? Erase this. Okay? The maximum permissible frequency is between 59.8 and 60.2. This is the Saudi standard. Saudi Electricity Company standard. The preferred one is 60.1 and 59.9. Okay? 59.9 and 60.1. So the band here is 0.2, the band here is 0.4 range. You see why it's 0.4 and 0.2? Ahmed?
61.2 now is 59.
So this is a 0.4 range.
Yes.
This is a 0.2 range. This is preferred. This is permissible. Permissible, yani 60.3 is not allowed. 60.2 is allowed but not preferred.
Yes.
And you can do it for a period of time, but you can't rely on it.
This one, the allowed the other one.
Yes. For the voltage levels, let's start from the bottom. Here with the star, it's telling you 69 kV, 34.5. Those are existing but non-standard. I mean, they are from the past. But after standardization, they're not standard anymore. The allowable limit is minus 5% or plus 5%. So any voltage more than 5% or below 5%, that's not allowed in the operation. Okay? I'm sorry, I have a quick call. So, the lower level, 33, 13.8, same story. These are standard now. Okay? The last, so these ones we call them primary distribution system level. This one is secondary distribution system. So S here is secondary. P here is primary. So secondary versus the primary. It means these one directly connected to a load. Yani to houses. These ones connected to service transformer. Then from a service transformer, they connected to the homes. Where do I find these two transformers? Maybe in front of your house, or your neighbor house, or maybe in between 2-3 buildings. The value on the right is, no, it's 3-phase, right? So the value on the left is line to line. We love line to line. The value on the right is line to neutral. If you divide 400 by square root of 3, you get this. Divide this by square root of 3, you get that. Divide this by square root of 3, you get this. Clear? The most common one is 200 for the homes. 400, 380 is for industrial loads or commercial loads. So distribution systems, substations include step-down transformer that decrease sub-transmission voltage to primary distribution voltage, اللي هو between 2.2 to 46 kilovolts, or 69 for local distribution. These transformers connect through circuit breaker. What is the circuit breaker? Big switch, 3-phase breaker. If you open it, the whole distribution feeder or line is not connected. And surge arrestor, they're against the surge of the voltage or current for protection. The distribution lines are also called distribution circuit or feeder. Two names. Distribution circuit or distribution feeder. Feeder is most dominant name. Each substation bus usually supplies several feeders. Look at this substation. We have here one feeder, feeder 2. This is also a feeder 3, 4. Clear?
هل في دكتور يعني عدد أقصى how many كم في؟
No, it depends how the size.
and how the
The number of loads is complex power should not exceed the voltage level. Should not exceed the power. Okay? The sub-transmission system consists of, oh no, not here. So basically the power and the distribution in the substation should not exceed the summation of all the power plus losses.
في دكتور one of the components or one of the machines in the power substation called GIS,
Stands for.
gas insulation system.
I think it's about some breakers that are gas insulated.
I think I read that it used for safety and something like that. For not for safety of the people, for safety of the
It
currents
is,
and voltage.
yes, it is possible. They have some switches that are gas isolated or breakers that are gas
Right.
isolated for safety. Yeah, it happens, but these are, again, these are more details. So if you're, I think there is a course called distribution here, but it's offered from time to time. If you're interested in distribution system, which is very useful, maybe you should take it. So generating plant, we have step-up transformer, circuit breaker, we have transmission, then transformer in bulk power substation, then we go to sub-transmission, then distribution, maybe we have battery, distributed storage system. Then we have, here we have feeder, maybe we have one phase feeder with a single phase transformer to the home, and it may have solar cell, maybe other services, or a three-phase where we have sectionalizing the switch. That's the name of it. Sectionalizing the switch from section. Section every feeder. It can be supplied with also solar or wind, and then they go to three-phase to other feeders. This is the general structure of the distribution. So here, all distribution. So you can see the energy storage systems are usually integrated with the distribution level. You don't put solar cells next to transmission line. Maybe you put it here next to generating plant. But the ideal place to put them is near the loads. Okay? Why they are important? Because in the PV plants, if you connect them to the grid, they might cause inertia in the generating plant themselves. Yeah. Do you remember the harmonics in 207? So you have sine omega t, sine 3 omega t, this is the third harmonic, or sine 5 omega t. This triplet or 5 harmonics would impact the generator. And then the generator inertia would not synchronize with 60, it might be 60.5, this is outside the range. So that's the problem with those renewable energy resources, is that they contribute to the harmonics component in the grid. Okay?
دكتور الهارمونكس هنا هل هي نفسها الفريكونسي اللي قاعدين نقول ما بين 39.8 و 6.2؟
No. Harmonics is 60 times 3 is what? 180.
Yes.
180 hertz will add up and change the original 60.
اي بس انه مثلا فيفث هارمونيك 5 ضرب الرينج حقنا.
It's not 60, it's 5 times 2 pi 60.
يا 2 باي الرقم اللي حددنا له رينج هذا
Yes.
ونفسه بالهارمونكس.
Yes. Typical distribution substation ratings vary from 15 MVA. Here what did we have? 10 MVA. So for 15 MVA for older, up to 200 MVA for newer substations. Distribution substations may include equipment for regulating the primary voltage, such as load tap changers. Here tap, load tap changer. Basically transformer, you change the winding, the ratio on the distribution substation, or separate voltage regulator. What's a voltage regulator? It's a transformer of 1 to 105. It keeps the voltage at 5% there. 1 to 1.05. So if you multiply it by 1.05, if the voltage is 10 kV, it will be 10 kV
10.5.
and 500
Yes.
or 50.
50.
50 to increase it by 50 volt. منظم. Typical primary distribution feeders, the feeder itself, the distribution line include 4 MVA for 4.16 kilovolt, or 12 MVA for 13.8. Don't memorize, you don't have to memorize, or 20 MVA for 22.9, or 30 MVA for 34. So what do you notice? A good rule of thumb is if you have 4 MVA, have a 4 kV line. If you have a 12 MVA, have a 13.8 kV line. Let's say 12. 30 MVA, the nearest in the 30s. This is easy rule to design the feeders from the loads. يعني if you have a load, they want 5 MVA, give them 5.5 kilovolt. If they want 30, give them 34.5. Go to the nearest one in the standard above. سهلة القاعدة? Did you get the rule? Right? Yes. If you have 12, give them 13.8 kilovolts. And the higher numerical value above in the standard. Now, can you operate 20 MVA for 34? Yeah, you can. But this is typically what happens. Don't give 4 volts for 30 MVA. That's nonsense. Okay? Distribution of electric energy from distribution substation to meters at homes. We have two parts. We have primary distribution and we have secondary distribution. Primary distribution and voltage level حقه is 2.2 to 46 kilovolts or 69. Secondary is maybe 120 to 480 volts. So this is close to your home. This is the infrastructure in the neighborhood. We have a 3-phase, 4-wire, multi-grounded primary system is the most widely one. 3-phase plus 4th wire for grounding. The 4th wire in these Y-connected system is used as a neutral for the primaries or as a common neutral when both primaries and secondaries are present. The 3-wire delta is also popular but not as popular as the 4-wire. So you have two common wire configurations. Now, here we have rural areas, urban areas. What's the difference between them? الضواحي المدن الصغار, they have low density population, and they are usually served by overhead primary lines. with distribution transformer, the fuses, switches, and other equipment mounted on the poles على أعمدة الكهرباء. In urban areas with high density loads are served by underground cable systems with distribution transformer and switchgear installed in underground vaults and in-ground level cabinets. The underground cable systems are highly reliable, usually unaffected by weather, but the installation cost is much higher. So if there is a fault in the line, you have to dig, you have to زفلة الشوارع مرة ثانية, so it's more expensive. Plus the faults here are more permanent. يعني if the line here gets damaged, you have to replace the whole line. And then you have to dig the whole line. وهذا سبب كثرة الحفريات.
عشان كذا البلدية مشغلتهم في الشوارع.
Most of the digging in the ground is from either water or electricity. Communication is not much. So what are the topologies for distribution? I need you to focus. This is the most important slide. We'll ask questions in it. The first one is radial. إيش معنى radial؟ شعاعي صح؟
Yes.
Here we have feeder, feeder, feeder. Here we have a recloser. Recloser, it's a breaker that open and reclose automatically. Programmed in a way to reclose solenoid or solenoid. We have a feeder. It ends with normally open switch, tie switch. Here adjacent feeder, another feeder. ممكن هذا from another substation. So here we have a substation. We have the feeder. Then we have lateral feeders. Those are usually single phase or can be three phase. Connected with a fuse. The fuse is a one-time switch. If the current is too high, the fuse will blow. Then this will be open circuit forever until they put a new fuse in the lateral load. So here are the homes. Here are the homes. So if this homes causes a problem, the fuse would isolate it from the system. If this home consumes so much electricity, the current will be high, the fuse will be blown away. Then we have a sectionalizing fuse. If this neighborhood causes issues, this section will be blown away. Keep this alive. If this section causes issues, blow it away. These are fuses. And we have a capacitor bank here to improve the power factor correction. If we improve the power factor, we improve the voltage levels here, because here we have voltage drop. Too many nodes. This is normally open switch. Let's say for some reason the adjacent feeder needs more electricity. We will go close this breaker, and once we close it, the power comes from here to the feeder that's adjacent and support the load. So that's the purpose of radial, is everything is radial. It can be increased, decreased the length using the normally open. This is normally open. Under normal operation it should be open. In special condition we can close it, connect the adjacent feeder so that we can supply power. So this is the loop. This is the radial. Here we have the loop. Here we have a cell breaker. Then we have a recloser. Here primary feeder 1, primary feeder 2. Let's say here we had a problem, maybe a fault. Electricity, the recloser will be open. صح ولا لا? And this recloser will be open. So this is isolated. What will happen to this load and this load? They will be out of service. So the operation will close this switch and get the electricity from feeder 2 to cover these loads. Now we improve the reliability of the system. Clear? Want me to explain it one more time?
Again, Victor, again.
Okay. How many feeders we have in the loop?
2.
1, 2. What is a breaker? It's a switch. You can on and off. What is a recloser? Time the switch. It opens. After a certain time, check the condition. It will close. If the fault is in the system, it will stay open. 3 times and then it will be permanently open. It's in the protection. Let's say here in this here we have an issue. There is a fault. A fault يعني short circuit. This transformer is what? From primary distribution to secondary distribution. Okay, that's why we have transformer. Let's say we have a fault here. What will happen? Electricity will go here. This will be open. This will be open. What will happen now is we have isolation. So no electricity is flowing from here. Load 2, load 3, what will happen to them? They will not have any electricity. So the operation will go and close this switch so the electricity flow from the healthy line so now even though there is issue here, we improve the reliability. Another scenario is what if we have an issue here? This recloser will open, still the electricity, this is on, this will be off. This tie breaker is on. Now,
Will be off.
no, because they are tied together. ما في هنا. لو كان هنا في R,
Okay.
لو كان هنا في recloser, we can close this and allow the electricity to move here and isolate this. So it depends the topology, how many reclosers we have, how many breakers we have, how many fuses.
طيب في سؤال دكتور.
تفضل.
لا تفضل. الحين بخصوص البريكر. ايش الفرق بين البريكر هذا والسويتش اللي هنا؟ يعني هذا مانوالي وهذا اوتوماتيك يعني ولا كيف؟
No, a breaker has more ratings. يعني it is closed for normal operation. Recloser is for protection.
مش هو اللي كذا، اقصد السويتش اليمين.
Switch. This is a manual operation. If they close it, they don't expect rated current flow. It's for temporary only because it's normally open. الريتنج حقت هذا is more. فهذا يصير أغلى. This is a small switch is a smaller. Plus this can be single phase. Breaker is usually 3 phase.
هل في ريكلوزر حق كل سيرفس تقريبا؟
It depends on the design. You might combine 3 homes in one recloser.
بس في العادي يعني
It depends. Old system, new system, standard, non-standard. What we need to know is the loop is used to bypass. يعني this same story. If we have fault here, this recloser will be open. This will be open. Isolate this. Now no electricity will flow. You need to close it. Electricity comes from here all the way to here. Or even better, we can have the hybrid, the network. We have radial, we have loops, we have multiple substations. This is the network system. That's the network system. Okay? So the primary radial system is widely used, economically found in low density areas. Single phase laterals or branches usually connected to feeders through fuses, هذه lateral, single phase. And these single phases are connected to different phases, A, B, and C, to balance the loading. Some of the loads will get phase A, some of the loads will get phase B, some of the loads will get phase C. The loop, if it's overhead, where high service reliability is important. The feeder loops around a loop area and returns to the distribution substation, especially providing two-way feed. You have two-way feed. Reclosers and tie switches are used to reduce customer interruptions and isolate faulted sections for the loop. Underground feeders faults occur far less frequently, but they are permanent. If a fault occurs in the underground, it's usually a big fault. While in the overhead, if the fault occurs, it might be a simple fault that can be fixed in 1 hour. But if it's underground, they need 24 hours, maybe 2 days, it depends. The last system is this is the underground loop, similar structure than overhead. Underground ما فيها recloser. Okay? النتورك سيستم
ادفانتج ولا ديس ادفانتج؟
لا الريكلوزر اذا علق لازم تحفر حفريه وتشيله. فالريكلوزر اذا علق وهو فوق تقدر تغيره بسرعه. الريكلوزر is an automated switch. The way it works, it will sense the voltage and the current. If it receives a signal from the relay, it will open. Count 4 cycles. Reclose. Get the data. Good or bad, still bad, open.
من نفسه يعني.
من نفسه. بعدين يرجع يقفل. 3 times usually, and it will be permanently on. خلاص open. So what will happen is you have to close it manually. If it's underground, who will close it? The power system is not automated. Everything is automated. No. Okay. We will continue next lecture the discussion about reclosing and networks. Okay. Any other question? So remember, we have quiz 4 on transmission. Quiz 5. Quiz 5 or 6?
4.
Transmission. This Thursday.